Welcome back to the Thermodynamics class. So today we'll be studying the first chapter, which is entitled, chapter 1. We can call it definitions. And introductory. Concepts. Okay, so the first thing to do is to be able to define some very important words in order to clearly understand everything when we're talking about thermodynamics. So we're going to start by very simple definitions. And I'm going to try to keep the definitions as simple as I can. So as I mentioned in the previous video, basically in thermodynamics, we're going to be dealing all the time with these different substances like water. And we need to know what is the state of the water, because we can find the water in different states. You can find water in state liquid, gas, or solid. So we need to clearly define each one of those words. So the first one we just mentioned was, what is a substance? So let's see, what could be an easy definition of a substance? So let's say a substance is defined by its specific properties. So basically what I'm trying to say over here is that different substances will have different characteristics or different properties. So then next thing we need to do is maybe define what is a property. So a simple definition of a property could be a property is a physical characteristic of a given substance. So maybe here let us try to give some example. So different types of properties could be what? The weight, the mass, could be the volume, could be the temperature, could be the density, and you will have a lot more. Okay? So now, we just said that, for example, for the water, we know we have the substance water that will be defined by its properties. And now we need to be able to define what will be the different states at which we can find the water. So basically we can find the water at the state liquid, we can find the water at the state gas, we can find the water at the state solid. That will be ice. So what is a state? So we can give the definition for the state and say that the state of a substance is defined by its properties. Okay, so basically we can say that so what happened is that, for example, if we have water, we can find water in different states. That will be, let's say, solid, that will be ice. We can find that in liquid, or we could find it as gas, that will be steam. So it's not difficult to understand that the different properties of the water, so basically the different properties of the states at which the water is, are different. And the easiest example probably is to think about what happens when you put a bottle of water in the freezer and you completely put water all the way up to the top of the bottle. You find out that the water is going to expand and the water is going to want to take more volume. Even though it's the same substance, one other properties did change, and that property was the density. So basically, even though it was the same substance, because the state is not the same, the properties did change. Okay? So basically, density of liquid water is not the same as density of ice water or ice. And the density of steam will not be the same as the density of liquid water or ice. Okay? So now that we have defined that, the next thing maybe we can define will be to say that since now we know what is a substance, a property, a state, we can maybe define what is a process. So basically a process will be the process between going one state to the other. So basically the process between the water going from state liquid to the water going to the state solid or ice. So a definition for state, so the process is the transition of one substance from one state to another. So basically we can just say that a process, we have a substance here, state 1. Here we have state 2. When you go from one to the other, that will be called a process. Okay. So after we have the process, maybe we can look at the different type of processes. So one process we'll see all the time will be called an adiabatic process. That basically means no heat added or removed during the process. So that could be another definition. Okay, so now we could go to different processes. There is also a process for constant pressure and another process for constant temperature. but I don't want to extend too much all the definitions over here. I think it's more important to go and maybe define the two different types of properties that we can encounter. So when we talk about properties, you will always be able to classify the different properties by extensive properties or intensive properties. So what is an extensive property? So an extensive property is defined as a property that if you want to find the final value of the property, you can add all the previous parts of that property. So for example, I think it would be easier to see that an example, and then I give a definition. Let's say the mass. Okay, so if you want to find what is the total mass in the room where you're standing, you can probably say the total mass in this room will be equal to the mass of the chair, the mass of that table, the mass of that lamp, and so on and so on. So an extensive property basically is that extensive property means that you can add all the amount of substance within the system. Okay? And the other type of property is called intensive, sorry. So that one might be a little bit more complicated, but basically I think that by giving one example would be easier. Let's put the temperature or the pressure. So basically if somebody asks you what is the temperature in the room where you're standing, you're not going to say that the total temperature of the room will be my body temperature plus the temperature of the table plus the temperature of the lamp, and so on and so on. So that property will be global. Basically it means that it's the same one in all the system. Okay, so that could be an easy definition. So the value of the property is global and remains unchanged within the system. Okay, so over here I introduce a new word over here in those new definitions, that is system. So let us give a definition for the system. So basically in thermodynamics, or really in any engineering course, every time you're going to solve a problem, you need to define the system that you're solving. So in thermodynamics, you will encounter two different types of systems. So a system, so the two types of system that you will find will be a closed system, and another one that will be called, I like to call it an open system to clearly make the difference. But generally in textbook, this is called a control volume system. Okay? So I think the easiest thing is maybe to do some figures. So for a closed system, that's the system we'll be using probably for half of the class, if not more. But basically, an easy definition will say that the mass of substance, or the amount of substance, remains constant within the system. Okay, so the classic example for a closed system is a piston. Piston cylinder assembly. So imagine this is the piston over here. So this will be the piston with the cylinder and so on. But what's important over here is that where will be your substance? Your substance will be within the contour or within the boundary that I created over here. So let's say we have here any substance, let's say air. So you see that within that little enclosure, the amount of mass of air cannot change. So the piston can go up or can go down, but the mass will never change. The other obvious example for a closed system will be, let's say, a closed box. Where you will have air again, and obviously the amount of mass within the system cannot change. So this would be like a box or a closed container. Okay, so the second type of system that we can use in order to solve problems is what is called an open system. I like to call it open system just to be the opposite, but you will see that in most cases it's called a control volume system, and you will soon understand why. So in this case, so over here, just imagine that you have any type of substance that is coming through this inlet, and then some other substance is leaving through over here. So the certain amount of substance per unit time, here I'm in, so dm sub I dt means the amount of substance that goes into the system per unit time, and we can replace the ddt by just the dot on top of the m, and that must be equal to the amount of substance that is leaving this box over here. And same thing, we can call this m dot. So why do they call this control volume? It's because basically it's defined that the amount of substance that goes within this contour or within this system over here, and that's what they call the control volume, okay, or system, So basically the amount of substance going in needs to be equal to the amount of substance going out within this control volume. But here there is the idea that there is not a constant mass, but that the amount of mass within the system will be the same, but that there is a flow of mass going within a control volume. So a simple definition for an open system of control volume will be the mass flows within a control volume. Okay, and I think this will be enough for this video, and I will be continuing posting videos on this class. So thank you for your time, and see you next time.